Hey guys, so in this new tutorial we're going to be looking at some more advanced randomization techniques for our shaders. Some people have asked about how to get more variations and randomization controls, and so we're going to look at a couple different techniques on how to approach this. First off, we're going to start off with something that some people have asked about, that they liked about F-Storm, which is another GPU renderer. They have a built-in UV rotation randomizer, which is useful if you want to tile panels on the ground and randomly rotate them. And so this is a little technique to do that. Obviously, having this built into the Redshift texture node or as its own utility node would be a bit more useful, but for now this is a workaround that works really well and lets you basically accomplish the same thing in Houdini. I'm not sure if this is possible in other apps, so we're going to just do this in Houdini, and the approach we're going to use is actually going to end up with an HDA, and that'll let us reuse it whenever we want. We'll also look at how to randomize a folder's worth of textures to randomly put them on our objects, and we'll eventually look at some more advanced stuff with material style sheets and overriding some Alembic instances and stuff. So that'll be how we wrap things up with material style sheets. So anyways, let's start off. We're going to just start off with the random rotation HDA that we're going to build here. So let's just drop down a grid, and actually let's just hold control, click grid, and we'll just drop this down, and we're going to just label this rand rotation, and we're going to just dive up in here, and let's make this grid a little bigger. Let's do 10 by 10. Let's move around. I already have a physical sun and sky set up, so if we just start rendering here, that's all we've got. I'm using the post effects build. This is build 2.632, so it's the latest. Nothing really fancy, just bloom and glare. And we're going to look at how we could basically make tiles on a ground. So this would be useful for ArchViz or architectural type stuff, or if you're making buildings, and how to rotate the tiles randomly. And so, cool, we've got our basic grid now. Let's pause that render. And let's just come in here, and we're going to have another grid. So let's hit tab, start typing grid, and so these are going to be the tiles we actually instance. So this is the grid we're going to instance on. So if you guys have a floor plan, this technique will work on different shapes. It doesn't have to be a square. It can be, you know, whatever you want. But so I'll kind of go over that in a bit. And we're going to have a grid, but now we're going to make the grid 1 by 1. So if we come in here, you'll notice that our box is basically the size of each of these, and we don't need any rows or anything like that. Okay, cool. And we're going to UV this, so let's type in UV project, and the automatic orthographic will figure it out for us. We don't need to complicate things. And let's drop down another UV project for our bigger grid. And now what we want to do is we're going to just copy to points. And so what the copy to points is going to do is going to copy this smaller grid that we made onto each point on our larger grid. And so we're going to just plug this side in. This is the points to copy to. So we're going to copy onto our bigger grid, and this is our, and let's expand this, and actually let's bring up the geometry spreadsheet so we can start to see this data as we start making it. And let's bring that down, and let's plug that in. Let's highlight that. And so right now, if we do a quick little preview render, our orientation is wrong. I mean, you can tell from the viewport also. And so we need to actually rotate this. We could rotate the grid here that we made. And so if we highlight this, we need it to rotate, I believe, 90 degrees, let's say. Yeah, negative 90. And now if we highlight this, they'll all be flat, as you can see. So if we do another preview, you'll notice now they're all flat. And you can adjust the spacing. I know that some tiles have spacing between them, and so this kind of, the way you could adjust that is either you can adjust the scaling of the smaller grid. So if we do something like this, you'll notice we kind of got rid of the gaps. Now they're really small. Or you could just overshoot it just a little bit so that it's fully covered, like that. And okay, cool. So now we've got our tiles. So we'll just imagine this is our floor, right? A kitchen floor or whatever, right? And we want the attribute to randomly, we're going to make a random rotation attribute, but not just random. We're going to make an attribute that we can actually control. And so that way, if you want angle snapping, 30 degrees, 90 degrees, only rotations, it'll allow us to do that. And so we're going to right click here. We're going to create an attribute. And actually, let's save this as an iteration here. Underscore 001. Let's hit enter. Okay, just in case, you know, anything happens, always good to save. And the attribute we need to make here is what's going to be basically controlling our randomization rotation. So we're going to give this a unique name. We're just going to, or we'll just call it rand for now, because the idea is we're going to actually convert this into a HDA, and so this will actually be controlled by the HDA later. Okay, where were we? Oh yeah, and so now we got to fill this in with the data. And how this is basically going to work, it's going to manipulate a user data node on our shader network that's going to control our UV rotation. And but before we do that, we actually need to make a control knob that we're going to use as a slider. So you could make this at the shader level, but since we're going to make this an HDA, we're going to use a null. So let's drop down to null, and using this null, we'll just call this rotation control, and we're going to edit the parameters, and we're going to add a float. Here we go. Pass that forward. We'll hide these because we don't need those parameters. We'll call this rand for rotation random. Or no, let's just call it rot control for rotation control. Rotation angle. Or actually, yeah, let's just call it raw angle. And this will basically give us a slider. The range for this is 0, so we're going to clamp it to 360 for a 360 degrees rotation, and we're going to hit apply. That's going to give us the slider here. We're going to accept. And so what we need now is to collapse these two nodes into their own subgroup. And so you could right click actions, collapse the subnet, or you could hold shift and C. We're going to hold shift C, and that gave us a subnet that it collapsed to. And we're going to edit this interface now, and we're going to just hide all these inputs because we don't need them. So let's hide all this. And right now, as you can see, we have our attribute, rand, that's running across our points. So let's hit apply. And we're going to want to make our float. And again, we'll call this, we'll just call this rotation angle. The label will be rotation angle. And again, we'll clamp this. I know that I didn't need that you don't need the null. You could actually reference this directly, but it's good to have the null in there just to kind of separate things. So we'll do that. And we also need a string attribute. And we'll use this to just give a name to our attribute if for some reason we have conflicting naming or something. So just let's just say rand or angle rand name, and we'll just call this name. Let's move that up. And actually, no, attribute name. So we'll call this attribute name. Apply. Okay. So this gives us our controls that we're eventually going to have on our HDA at the top level. And actually, let's add a little divider. Let's add a label. And a divider. Where's it at? Separator. Move that. For some reason it's, there we go, move that down. And the label, we'll just call it random rotation, random UV rotation tool. Or we'll just call it random UV rotation. So there we go. Let's duplicate the oops, not delete. Let's add another separator in there. Let's duplicate this. Move it up. Let's apply random UV rotation, attribute name, rotation angle. Let's make another one of these. Just to have a little neater UI. Okay, cool. So now we've got these parameters, these options, and so now we want to copy the parameter. We're going to come in here, and we don't need any of these, so we could just move those away for now. We're going to come in here, and under our attribute create, we're going to paste the relative reference right here for the name. So if we come up and we type in rand, we've got rand now as our name, or we could type in rand angle. And the reason why I have this here is just because rand, you know, it's pretty common to use that as an attribute name, so you don't want the same attribute name. So this lets you kind of change it whenever you drop it later on as an HDA. That way you don't have duplicate attributes, so you could call it whatever you want. And we're going to just use rand angle. Yeah, we'll just use rand angle for now. And now we're going to copy this, and we're going to jump in here, and we're going to paste it into here, and we're going to copy this, and we're going to need to write an expression into our attribute creation. So in our value, and we want this to be a point float, we're going to hold Alt E, and this brings up our expression parameter window, and we're going to type in our expression here. And so basically what we're going to have happen is we're going to drop a floor, and what a floor does is it basically gives you the next, it rounds to the nearest full number. So we don't want our angle snapping to be too weird in angles, so we want it to be full numbers when we're actually doing rotation snapping. So we're going to have a floor, then we're going to have rand, which is random, and we're going to have $PT, which is point, PT, our point numbers, and we're going to close that. And after that, we're going to drop in a multiply by 2. We're going to get rid of 1 so that it maintains positive numbers. We're going to close all this, and we're going to now multiply all of this by 360, because that's how many degrees we are going to rotate our UVs. So there's 360 degrees. And we're going to reference our channel that we, our rotation channel here. So we could just, oh, I guess it didn't let me paste it in. Let's copy this. And it's not letting me paste it in. So let's just manually type in channel, 2 dots to go up a node from here to go out here, and we're going to start typing in rotation. I should probably use the capitals. Rotation control, and the attribute was rod angle. Oops, misspelled. And that should do it. And I forgot a quotation right here. Rod angle, and close this. Okay, and so that should reference this node and this attribute. And so we've got, how many parentheses we got here? We got 2 over here. So I need 2 more. And we're going to multiply this whole thing again by this same attribute that we got here. So we're going to just copy. And actually I need one more parenthesis. Okay, so this should work. So this is, let's see, let's just apply, see what happens. Okay, yeah, so it's got it in there. So this is 0. So if I adjust this, let's go up a bit. Oops, went too far up. If I adjust this angle here, let's just type in 90. You'll notice right here, okay, we've got angle snapping. Our attribute here, you can see rand angle. And so it should only be doing 90-degree turns, 90, 180, 0, negative 180, 360. Yeah, okay. And just to be sure, let's jump in here. Our value, yeah, okay. So from the looks of it, it's working. So if we, let's bring this up. We're only getting 90-degree turns. And so if I make this rotation angle 30, we should only be getting 30-degree turns. 60, 0, 90, 210, 270, 30. Yeah. So it seems to be working. So now it's generating our numbers, right? Based on, as you can see when I slide this, it's making all these numbers. So if I have it at 0, there's 0 rotations. If I have it at 1, it's going to do 1 through 360. If I have it at 90, only 90-degree rotations. Okay, cool. So it appears to be working. But before I convert this into an HDA, let's test this out. So we're going to come in here and drop a shader on this. So that's material, and actually let's go to the material section and let's delete this for now, and we're going to just make a builder, and we'll just call this or we'll just leave it, doesn't matter. Let's make a redshift material, snap that in, and let's bring it to texture so we could see the rotations, and we'll just plug this in as diffuse color. And if we check in here, I've got some numbers. So let's just use the number 13. So it's obvious that we could see that it's rotating. And now the trick to this working is the attribute, rand angle attribute that we created earlier. And you can name this whatever you want, you know, using the HDA. This attribute needs to be then put inside of our user data node. So we're going to type in user data, and we want integer, because this is integer data. As you can see, there's no floats. It's, you know, 90.0, 96, 180. It's not 180.54 or whatever, you know. It's not float, it's integer data. And so we're going to plug this in, and where we want this to go is inside of our remap. This is our UV remapping section. And so you could tile or scale and do that type of stuff in here, but there's also a rotation option. And so this is going to be controlled by our integer data. So we're going to plug this in, and let's see, into general, rotate. So if we click on this now, it's plugged in, and the name we're going to use for the attribute is the name we made. So rand angle. And cool, that should work. So let's go up to our object. Let's highlight the material SOP, and let's load in our texture. And for now, let's just keep this at 0. So this is default, no rotation snapping. And let's actually save our scene. Let's hit play. And whoa, something weird's going on. And I think it's related to our UVs. So let's check that out. Let's pause that for a second and dive into our UVs here. And let's highlight this. Let's see what's going on here. Okay, so our UV right here, because we rotated it, the UV rotation's off. So let's instead of method to best plane, or actually we could just hit initialize and that should automatically fix it. Let's make sure. Let's try this again. Yeah, there we go. Okay, yeah, so because I rotated the grid earlier, I needed to also, and I put the UV project first, I needed to reinitialize the best fit, or you could just manually select the angle. But okay, now that we've got that working, let's zoom out and let's actually look at the like a top view or something. So as you can see, we've got our tiling geometry, and right now, because our random angle is 0, so is our rotation. We have 0 rotation. Now if we make this 90, look at that. We now have 90-degree snaps on our rotations. If we make this 30, got 30-degree random rotations. 5, you know, and so on. 180 will only give you 180-degree rotation, so it's either up or down. 90 is pretty, you know, like pretty useful. So you could see how this works, how this is randomizing. So in practice, what you know, how does this become useful? If you know you need to tile floors, and let's say you're using one diffuse texture, you can have it randomly rotating now, and you could also use a randomly rotating reflection. So let's actually try that out real quick with a shader, and then we'll convert this into an HDA. And you guys will get the HDA for free. It'll come with the files. So let's dive into matte, and let's jump into our shader here, and let's make another texture. Or actually, yeah, let's make we'll just load up a new texture. So instead of loading up the numbers, let's go back up, and we're gonna load up an actual tile, like a floor. And so let's copy this, paste it, and we're going to enable it to be linear. And again, we're going to have it connected because we want the normal map to obviously match the diffuse map. So this data is still controlling the rotations equally the same. And let's drop a bump node, and we'll plug this in to the input. We're going to switch it over to tangent space normals, and actually on our object, let's make sure the redshift attribute to calculate the normal maps from the UV is checked on. And let's actually do a quick mark in here, and let's come in here, do another quick mark. Let's save. Scoot this over. A little bit. And we'll plug this in to our bump input. And let's do another texture sampler. And instead of normal map, we'll load in our roughness map. And this one, we don't want to use the same data. Well, no, we can. We can. We'll have it just match the rotations. But I mean, if we wanted different rotation snapping, we could just duplicate this node and change the attribute. So actually, we'll do that. So let's first save this as an HDA. So there's several ways you could save this. You could create digital asset, and we're gonna call this the random UV rotation. And we'll just call it RS, even though this SOP will work in Mantra or other renders because it's just generating attribute data. Other renders that support attributes like Arnold and the Redshift, Mantra, it'll work. So this will work perfectly fine. But we'll just call it RS because I like to keep things Redshift location when we hit tab. So yeah, let's just accept that. We can give it a different icon if we want. Let's just do that right now real quick. We'll go to the why is it not showing up? Oh, there we go. So gotta just go to the home up icons. Oh wait, it's not showing up. Strange. Okay, I don't know why the icon folder it's not showing up when it totally should be right there. Okay, that's weird. Yeah, strange. I don't know why it's not showing up correctly. And okay, I figured it out. So it's the icons right here. There we go. So yeah, this is a list of all the icons that ship with Houdini, and so we're gonna just look for something that's looks like a UV map of some kind. I mean, it's not really that important, but nice little icon so we could tell what it is still useful. And actually, I'll just pause the video while I look for this so I don't waste you guys' time. So cool, settled on this blue grid icon, and yeah, there we go. This is our HDA, and we'll just call it RS random UV rotation. And I think this is This is good to go. Yep. Let's yep, okay. I think this'll work for a little node. And actually I've been meaning to do this myself, so I finally got around to doing it. So now in the future, if I need to do it, I could do it. So we're gonna save that. And so cool. Now we've got our random rotation node. And you know, as you guys know, I have my redshift scatter instancer node too that I made in the past. And actually let's oops. Let's change the not the color. What's going on here? The shape. So maybe we'll have yeah, I think that's fine. Just something different so we could differentiate it. Oops. Okay. And let's actually save that asset. Okay, cool. So if we duplicate this, so let's actually drop down another one of these RS random rotations, and we move it down. And this time we're going to call it rand rough. So this is our random roughness of our shader. And we're going to use, I don't know, 30-degree snapping, so more randomness, while this one only uses 90. And so let's come back down here and let's hop into our material, and we're going to cut this off, and we're going to copy this, paste it, but instead of using rand angle, we're going to use rand rough. As you can see, that's this data. And we're going to plug it into the same slot though, our rotate. And so this is now using our roughness. And we're going to plug that into our roughness controls. Let's switch this to GGX. Let's move this down a bit. And then cool, let's save. And so if we load this, we're going to be using these textures. And yeah, there we go. Nice. So we've got, if we look at things, we've got randomly rotating ground. And actually, let's make a gap so you guys could see where the grid is a little more. So let's go to the object. And on our grid size, we're going to just make this 1.1. And that's probably too small. Let's just do 1. So it's a little more obvious. Or actually, maybe 1.1 is better. And we'll just look at it from underneath, since the texture is kind of like the color. Yeah, there we go. So you can see that each diffuse map is changing angles based on 90-degree angles. And our specular map, even though it's kind of hard to see it in there, Our specular map, though, is rotating more often. It's rotating at 30-degree angles, but it's just a little harder to see. And that might just, let's do a color correction. Let's see if we could. Or maybe we'll do a ramp. And that'll just help us see it a little better. UV map. No, Alt. And let's try to crunch it. And actually, I think this, oh no, it is using roughness. It's just hard to see it. The map's not that obvious on where roughness and stuff is happening, but it is happening. So this basically lets you guys make a floor that's a little more random. And maybe we'll just crunch up the exposure. Give it an S curve. So if we were to actually just make another grid, let's pause this and let's make this grid 10 by 10, same size, but our material, let's just make a material. And we'll make this a really dark color. Really rough. Let's go back to our object. Let's assign our material and let's load that up again. And actually it's too high up. So let's lower it. Right there. You guys can see how this could be oh, now the specular is working. I think I just had to reload the IPR didn't update. So, okay, now you can see, look at this. We got some nice tiling floor here. It's a little too shiny, but that's okay. And it's rotating around. And let's actually, in our ROP, slow our secondary subsampled intensity so the bloom isn't so strong. Let's keep it at the default. And so as you can see, our tiles are rotating randomly. The diffuse map and the normal map are matching. But our roughness map, we're rotating separately. So if we come into our object here, and we adjust this one, we'll get different rotations on our roughness. It's subtle, but you could see it changing. So if we were to use 90, it would match exactly the same beneath. And actually, it might be good to match the bottom the same and then add a clear coat on top, which would have different rotating noises and stuff for more variation. But yeah, I think you guys could see how you could use this technique to now randomize if you're making floors and you want them to rotate differently. So we could rotate this 30 degrees instead of 90. And you'll notice how even though it's one texture, it looks like it's not repeating as much. And it just feels like they're different tiles. All thanks to just a little trick using the random rotation. Cool. Alright, so that's one way to get variations, random rotations on your UVs. And so now we made a HDA. I showed you guys how to make an HDA doing all this. And now if you ever need to do this with tiles and randomly rotate, there you go. It's an option right there. And like I mentioned earlier, it doesn't have to be a square floor. It could be pretty much any other shape you want. So we do 5 that way and 20 this way. You'll notice how the tiles are spaced out. And that's just due to you could either adjust the size or you can adjust the row count. So we need more rows. So we could bring this up. "20 rows and 5 columns, 6 columns. Let's come in here. Oops. And we could increase or decrease the size depending on, what we want to do. If we want big gaps, we could keep it like this. And we just gotta make the ground beneath it match. Obviously the ground's now a different size, so if we do 5, 20, now we've got our ground here. And you just basically adjust it. So the shape, the only thing that matters is that it's a grid. And we could adjust this to, I don't know, we can increase the size here. And now it's just a solid piece. Let's do 1.2. And let's adjust the size here. 17. There we go. That might be too big. But you get the idea. So there we go. Just after, making some adjustments to match the new shape of the floor. Yeah. This pretty much lets you and that's why it's not lining up, it's not centered. So let's delete the there we go. Should be centered now. But the width of the darker floor needs to be widened. Yeah, cool. Right now it's 2. So there you go. Once again, we've got our random tiled floor, but now it's a different shape. It's, and you could do the same thing by extruding edges and all that, as long as it's a grid shape. Because how it's working is it's basing the tile positions on points. So if the points are square grids, they're evenly spaced, then it works. Obviously, something more advanced would be if your spacing is rectangular, then the tiles you're duplicating would have to be the same matching rectangular shape. But you guys can mess around with that yourselves. And yeah, this just using this technique, we've got our random rotations on our floor. Cool. So I'll just keep this file here, and we're going to move on to the next more advanced randomization technique, which is going to involve how to randomize the textures that are in a folder. So like, for example, we've got our 1 through 20. How can we make it randomly switch between the folder of textures? And so we'll be using an attribute and material override to do that. And the material override lets you do lots of things. You could override a whole bunch of things, but I think material style sheets is a little better for that. This is just if you just need to randomize a folder of textures. So okay, cool. So yeah, I'm gonna pause it for now. I'm gonna save this, and then we're gonna move on to the next project involving randomization of these numbers in a folder. Hey guys, so we're back. We're gonna now test out how to randomize a folder full of textures. And so I mentioned earlier the textures we'd be using would be all these numbers here, and we just randomize them. So I'm going to go over the process on how to do that, and it's actually really similar to this. And I actually extruded the tiles just to give them a little depth. So let's open up the render view. And just so you guys know, if you're wondering how I did that by clicking this and it's not automatically starting the render, because I prefer to do that, if you right click your render view and you go to edit tool, in the newer versions of Redshift, I believe starting in 2.625 or 30, Normally this right here says IPR, and so if I click it, it automatically starts rendering. But sometimes that could be a problem, you know, if you're working on a really heavy scene, you don't want to just start the IPR. Maybe you just want to do final renders. So that's why I prefer to disable the IPR option, and so when you click it, it just loads up, and it doesn't start rendering until you actually click render or preview. So yeah, let's just move around so you guys can kind of see what's going on. So I just came in here and extruded the tiles and added a little bit of bevel. Nothing fancy, but as you guys can see, all the textures are randomly rotating, and you know, it makes the tiles look a little more random because, as I mentioned, if I were to disable that and just make that 0, they all, you know, you could tell it's obviously repeating. And so it doesn't look as good having all the tiles repeat like that. So it's better to have that random rotation. Okay, so anyways, let's pause that. Let's move on to the next randomization technique. So, and we can actually just kind of copy paste this, but we're going to make a new one. So let's drop down a file. And actually, let's call this random image textures. And let's delete this. And let's start off with the a grid. And actually, let's hide this so it's no longer in the way. And why is it still showing? Is it goes to other objects? Yep. Ground. No. For some reason, this is still showing when it shouldn't. It's kind of weird. Not sure why it's... Oh, it's just a regular grid now. My mistake. So let's... we'll do the same thing. So we'll have just this grid. And we're going to scatter some more points on it. So let's make another grid. And we'll make this, let's just make this 5 by 5. And we'll make it scatter more later. And we'll just do 15 by 15. And for this, we'll just make 1 by 1. And let's do another copy to points. Plug that in here, plug that in there. And right now they're sideways. So we're gonna rotate them like that. And so what we want to do is we want to have different textures for each point. So let's drop down to material, and let's do a quick mark. And actually, let's bring up our geometry spreadsheet so we can see what's going on. And so let's go build a new material, and we'll just make another builder. Oops. And actually, let's call this rand UV matte, just so we know. And this will be rand text matte. And so this will be random texture matte. And let's drop down an RS material, surface. And actually, let's open up a little so we can bounce around a little faster. The operator tree, we'll just keep it here. Let's make it a little easier to just jump around. And let's drop down a texture. We'll use that as diffuse color. Let's just give it 0.4 roughness, and that should be good to go. So right now, if we let's move this to the side, go to our Patreon folder, textures. And here's our folder. And let's just do texture 3 just for an example. And let's actually go to our objects. Let's come in here. And put our material down, our random texture matte. And so let's just render this and see what happens. Nothing. If we zoom in, and I believe that's because we don't have UVs. So let's pause that. Let's make a UV project. And best plane should work. Let's test this again. Yeah, there we go. So now the texture's showing up. It's just there. You could see it. Just the texture's a little bright. So let's actually make it a little dimmer. Where were we? Texture. And let's just override the color multiplier and make it a little darker. Just make it a little easier to see. Alright, cool. So we've got our texture showing up. And let's actually make our base squares a little bigger. Just for, and I'm going to add a quick mark here. And a quick mark here. And let's make our base squares actually that's not going to work. Let's or no, it should work. I just gotta reinitialize our projection. There we go. All right. So if we zoom out, you've got our number 3 texture. And so let's pause that render. What we want is we want whatever textures we have in this folder to be selected. Now, in order for this to work, you need to do several things. Your texture folder, they all have to have numerical naming convention. So if you look at the file names, it's numbers texture underscore 0, numbers texture underscore 1, 2, 3. They're all in order. So your textures, they can't have different names. They need to all have numerical order. So if you have a folder full of random textures and you need to name them, you know, in order, instead of having to go in here and one by one type them, you could select them all. And there's tools to let you rename everything. And so one of the tools that's free is called Bulk Renamer. And so, and actually let me show you guys the website. So yeah, if you just Google Bulk Renamer, you'll get the Bulk Rename utility. You can just click on it and you can download it. It's free. And so what this tool lets you do is if you select the folder of files, any kind of file, and you just click Bulk Rename here, it'll open up the tool, the utility, and it has all the names. And so all you have to do is just select the files, and under name you can change the name to something, so like test underscore, and so it'll show you the original name and the new name. And actually I wrote text, it should be test underscore. So you see how it's test underscore. And so if you want to give it numbering, right here in the options you have numbering. You could add dates. There's just tons of options. It's really powerful, free utility. And so we're going to do a suffix, and there you go, automatically added the numbers for me. And you could add padding if you want, so you could have, you know, 4 padding, and whatever else, you know, whatever options you need. So we don't need any padding for what we're going to do, so this is fine like this. But we're not going to rename them. I already used that tool to name everything correctly, so I don't have to worry about that. But this is an important step. The files must be in numerical order. Otherwise, this won't work. So, okay, cool. Now we've got our texture appearing. It's only one. And so we want to have random textures on each of these tiles. So we have 0 through 20. So 21. We need to generate 21 random integer numbers. And so several ways we could do this. And for our purposes, we're just going to use a similar technique that we used earlier, using the PR and point number, primitive number system attribute in order to override the material. And so in order to do this, we need and something to keep in mind, this does not work with packed primitives, because basically what a packed primitive does is as soon as you pack it, you lose it becomes a point, and so you lose the attribute data that we're going to read, which is the primitive number. And you could do this with material style sheets also, and pack. That's actually what material style sheets are for, but that's the next part we're going to go over later, which is using material style sheets to do this type of stuff. This is without material style sheets. So yeah, what we need to do is we need to use overrides that use local variables. So we need to have this on because the variable we're extracting is the primitive number, which is each one of these squares. So 1, 2, 3, 4, whatever, right? The primitive number ID that's being assigned. And from that is how we're actually going to override our texture attribute. And so if you're kind of wondering where the this numbering is coming from, it's basically the intrinsic primitive numbers. So if we come into our primitive options right here, so you have point, vertex, primitive, and if you go under intrinsics, we have type ID. Or no, index. Is it index order? Yeah, index order. And so this is giving you the intrinsic ordering of every object, basically, of every polygon that we're scattering here. And actually, for our grids that we're scattering, we should just have 2, like that. And that'll just give us more appropriate intrinsics. And so this gives us 0 through 24, which is 25. And so we've got 5 by 5, which is 25 squares. So 25 intrinsic primitives. And let's just hide all that. And so, anyways, before we can override this, or we can override it, but the problem is the overrides do not work. So let's actually go to the material. We can't inside of here. The idea is that we're going to override our texture, right? But Houdini does not let you make overrides, and this is true also for material style sheets. It does not let you make overrides in map context to assets inside of a builder. So you can only override stuff that's out here. And so in order to override this, what we have to do, we're going to cut that. So we need to actually expose this parameter so that this parameter is up here on our settings. So in order to do that, we got to make a new parameter. We're going to make a new file directory. We're going to call this text 0, and the label will be texture, or let's just say diffuse texture. We'll hit apply, and we're going to paste our texture in here, and we're going to right click this and copy the parameter. Then we're going to go inside and paste the relative reference in here, so it knows to get whatever texture we type in here, it's going to add it to here. So now if we let's just preview this real quick. If I change this to 1 and reload, it's going to be 1. Change it to 4, it's 4. Okay. And so the reason why we have to put it on the builder. You don't have to do this if you would have built, if all this existed out here in mat context. But because it's inside of a Redshift material builder, we have to expose this parameter up here. And unfortunately, I can't just right click this or hit one of the gear icons to expose it. Like, let's, for example, the reflection weight. You can click on the gear icon and just click promote parameter, and now it's up here. See? But because the texture sampler, you can't promote this for some reason. I don't know why they don't let you. So we have to manually build one using the parameter interface options. So just something to keep in mind. And let's actually break that so that way it's not here anymore. And actually, I've debated to make my own custom HDA that'll have a lot of these options already at this level so that the OpenGL preview will look better. But speaking to Huango, the developer for the Houdini plugin, he says he's going to make one soon. So I'm not going to bother anymore. Okay, well anyways. So now we've got this here. And what we need to do is this parameter needs to get overridden by our local override. So we're going to hit the plus button. And you'll notice that it automatically, when you click on choose parameter, it automatically detects all the parameters available on our shader. So if we come back over here, you'll notice that we have material ID, our diffuse texture, and our OpenGL options. And so all those options are right here exposed. So we're going to pick diffuse texture. And the type is a string. Now obviously here it's giving me an absolute path, which we don't want. So let's actually come back up here and copy this. And that should still work. Yep. And so if here I change this to a 2, it's a 2 now. But if we look at this, it still has the 4 selected. See? Even though the 4 is selected here, this doesn't have precedence. The override has precedence. So this override option is taking over this parameter. Right? And so what we need to do now is we need to give this an expression so that instead of picking a number, it's going to randomly select one of these numbers. And so we're going to come in here and we're going to just delete that for now. And basically what we want is we're going to do a backtick, and actually let's open up our expression editor. Makes it a little easier to see. And so let's do a backtick, parenthesis, and what we want is integers, because we only want 1, 2, 3, 4, 5. We don't want floats. and we want this to be rand. And so rand for random. And we're going to do $$ PR. And so if you look at PR, if you highlight over it, and don't know why it's not showing PR. Oh, well, I don't know. It's not showing a little information about PR, but whatever. PR is basically the point primitive. Not the point primitive, the primitive number. And we're going to close that off. And so now we have the integer random primitive number, and we need to lock in how many to randomly, what numbers to generate, because right now it'll just generate an infinite amount of numbers, and so it's not going to select only our textures. It's going to make numbers that are way bigger than we have textures, and so nothing will get selected. So if I actually let's just show you what the oops, I need to close this. Another back tick, and actually I'm missing another parenthesis, so this should work. Oh no, I'm still missing something. 1, 2, oh, one more. There we go. So if we look at our primitive texture, our primitive spreadsheet, you'll notice over here, here's the textures it's randomly selecting. And right now it's all choosing 0. So the override isn't working like we'd want it to. And it's just going to be zeros. And the problem is because we have to specify how many points we're actually trying to randomize. So because we have 0 to 20, we want to randomize 21 textures or points. So after this PR, we want to multiply by 21. And there we go. Now that we've multiplied by 21, you'll notice we have 13, 16, 10, 4, just a bunch of random numbers. So if we press play now, there you go. Random textures are being selected. And so basically what this little expression's doing is it's saying our numbers texture, and it's saying pick a random primitive number multiplied by 21, which is our total texture count. So it's going to generate numbers between 0 and 21 randomly and make those numbers integers, so there's no floats. And those values are going to be what gets made at the end of our texture name. So it's numbers underscore texture underscore random numbers between 0 and 21 integers .jpg. And so that selects randomly one of these textures per each one of these random points, or primitives, not points, per one of these primitives. So hopefully that makes a little bit of sense as to what's happening here. Right? So, and actually I'm going to copy this code just so I can leave it in a notepad document for you guys later to use as part of the files. So yeah, that basically lets you randomize your textures on your objects based on a folder full of textures that are all named the same way. So hopefully that's you guys kind of understand what's happening here using the override parameter system. And like I said, you must have the override use local variables. If I disable that, you'll notice that all these numbers turn back into 13s, and that's all we're getting, 13s. So make sure that's active for this to work. I also want to quickly mention that actually this does work with packed primitives. I made the mistake of not checking. So yeah, just so you guys know, if you do indeed pack an instance, the material randomization works just fine. So yeah, so if you guys need to override any textures or attributes on your shader using the override system, it does indeed work with packed instances. And actually, now that I think about it, we need to activate packed prims for that to be, these are not actually packed and being instanced by Redshift right now unless we activate the instance stop level packed prims. So let's save this, check that on, and no, see, there we go. So now it is actually missing the shader data. So okay, so when they actually instance as real packed prims, even though our material override here shows that they indeed should be randomizing, because of the way that packed primitives works, all that data is basically removed at the instancing level due to being packed prims. So this is where material style sheets again come in and take over. So I'm going to go over that, and actually we're going to use the last lesson's tree data that we generated using SpeedTree, and we're going to actually process it to loop one of the trees. I kind of briefly touched on it, but it was going to take a while to cache. So this time I'm actually going to show you guys how it's done, and we're going to use that tree to scatter, and we're going to look at how to override the tree shaders and the properties on the shaders using material style sheets and all the cool features that material style sheets provide. So we'll be moving on to that next. Hey guys, so we're back. I brought in one of the alembic trees, and actually I'm going to show you guys a couple tricks before we start adding the material style sheets to the alembic tree. And one of them is how to make it loop. And actually, let's get rid of all this stuff. So let's rewind it, and I just press play. You'll notice we have our wind and our tree movement, but right at the end, it doesn't loop smoothly. So you'll notice, boom, it kind of like resets. And so that's basically a problem. And also the method that's output, when we use SpeedTree, we ended up using the HD5S or whatever. Let me check the name. It's the HDFS or HDF5. And so that format is really old. It's slower. It makes bigger file sizes. And so I did some researching, and it turns out that SpeedTree has a bug that they still haven't fixed in the latest version, where it cannot output the newer, better Ogawa Alembic system. If the file size gets bigger than 2 gigs, it just becomes empty. And so that's why when you load in a file that's Ogawa from SpeedTree, it just doesn't work, and you have to use this version. And so I'm going to show you guys how to convert to Ogawa, and you'll see the performance difference in a bit. And we'll also clean it up and just process it and make it loop. And so in order to do that, we're going to come in here, and we're going to actually cut this for now. We're going to apply these materials later. And so we've got our giant tree here, and what we need to do is we first have to, and actually let's no groups. We're going to turn no groups off, and we need to make sure that it's an unpacked primitive, because we want all the data that's in here. And so that when we convert everything, all the groups come over. So first thing we're going to do is we're going to do a clean SOP, and we don't need the degenerative primitives. We just want to get rid of the NANs. I actually reported that bug that would crash due to velocity NANs, and Dwango already fixed it. Dwango's fixed it in the 2.632, but it's still a good idea to just get rid of that data that we don't need, because it's empty, it's useless. And so we're going to do the clean SOP. We're going to drop down some normals, and we want these normals to be point normals. And after that, let's zoom out a little bit. All we have to do is basically process this out. And so underneath the ROP, Alembic ROP, we obviously only want to process the frames we have. So our Alembic file only went up to 71, I believe. Yeah, 71. And the format we want is Ogawa. And we also want to activate build hierarchy from attribute. This is important, otherwise we won't have our groups for our shader to assign these groups. So keep that in mind, our material groups. Alright, and to make this loop, make sure you guys have the game development toolkit installed. It's free, comes with Houdini. You just gotta click the update and it'll update. And use the looping tool. So if you start typing loop, you'll get the game dev make loop. And pretty much this already default works fine. it's going to start from frame 1 to the end of your project's frame range. And so since our alembic tree is only 71 frames, we're going to add that there. Give that a second. And we're going to actually write this file out. And we're going to put it in the same location that I have my original. And let's go to the right. And we're going to add loop to the file name so that we know this is the looped version. And yeah, it's good to go. All we have to do now is render to disk. And that'll process our tree frame by frame. And actually, oh, oops. Right now it's only on render current frame. We want to render the frame range. So 1 through 70, 71. And actually, let's save this and render this to disk. There we go. And so it's going to go through all 71 frames one by one and process our loop so that it animates and it loops unlimited, like perfectly smoothly. This is a really cool node because it makes any frame range loop. And so we're gonna give this a couple minutes. I'm gonna just pause the video so you guys don't have to wait 5 minutes or whatever while this processes, and then I'll show you the difference with the new Ogawa Alembic, which is smoother and faster to process in the viewport, and it's in a loop nice and smooth. So alright, I'll be right back. Hey guys, so we're back. Everything is finished processing, and I'm gonna just make another Alembic SOP. We're gonna read in our summer loop, and so we're gonna do a little comparison. So this time it's highlighted, and let's actually bring our groups. We want shape node groups. That way we still got our groups. And if we just play this forward, the processing time is actually quite a bit faster. And even though the file size is a bit bigger due to the looping. And come to think of it, we might actually not need the velocity attributes, so we might be able to actually make the file sizes even smaller, because our velocity attribute can now be computed directly from our moving, deforming leaves. And now that it's playing back, I mean, look how much smoother this is. This playback is just fast. And that's just due to Ogawa being a more efficient system. It's lighter. It generally is a smaller file size also. And as you can see from the loop, we're getting a nice loop. Let's see here. 71. Yep. And so now we're getting a looping tree. And actually, I think I went a frame over, and it should have been 70, not 71, because now the loop doesn't have that delay at the end. So I'm going to actually re-export this real quick. But yeah, as you guys can tell, the playback is just much smoother. And now we've got a looping tree that infinitely loops with wind. And it's an alembic file, which is great. That means we could keep it as a delayed primitive, and we can only load in parts that we need, and so on. So an alembic is it's a good file format to keep. So yeah, let me actually re-export this. So we're gonna do this all over again, and I'll reload it back in, and then we're gonna just attach our transform and our material to it. And I already have another 2 trees that I've already pre-processed that loop fine. So we're gonna, after that, check out how to override the materials on our tree using the material style sheets, and how to randomize our properties. So let's say we want to adjust the hue on the leaves or something, and we could do this many different ways. So we'll be going over some of those really cool options that material style sheets provide us. And a lot of this stuff isn't in the documentation yet, so a lot of people don't know that you can do these things unless you're reading a lot of the forums, which I kind of do. So hopefully I'll go over most of what's supported right now, and you guys will now know how to use material style sheets in combination with Redshift, which is one of the more powerful features Houdini has that I think is really cool that other applications don't have. So we'll be back in a couple minutes, so I'm going to pause this and I'll be back. Hey guys, so we're back to our scene, and pretty much I just added a little time warp with our input frame range, which was 1 through 70, and an output range of our total scene, and just had it post cycle. What this will do is it'll just loop infinitely. And so even though we had only 70 frames, because our 70 frames looped, you could just loop it and loop it and loop it. And I did a quick what's it called? A play blast, and you can't really see too well, but yeah, the leaves are moving around and stuff, and it just loops perfectly. So cool. And so I know that some of you guys might be wondering how you can turn this loop into a longer loop. Well, that's how you do it, using using the time warp node and just making it post cycle, and so it'll just continue repeating. So anyways, let's clear our cache. Oops. Window, where is it at? Cache manager. And we're going to just clear the cache because it's taking up a lot of RAM right now that we checked out the animation. Let's hit the D key and change the background display to back to light. And let's just clip our frames back down to 70. Yeah, let's just disable that since we already have it warping. It's, not warping, repeating. So for our next step, we're gonna actually override the materials on this using material style sheets and look at the process of how how and what we can do with material style sheets. This might change in the future when dealing with alembics, because there's an alembic procedural being worked on right now, and I've actually been testing it a little bit, and I don't know when it'll release, but it's what an alembic procedural does is it's basically like a proxy. Your alembic file is scene deferred, and so Redshift will actually load it only when the arrays hit the bounding box of the object. So it's exactly like a proxy file basically. But yeah, that's not ready yet, so we don't really need to worry about that right now. But it's something to keep in mind in the future, and I'm sure everyone will know when it happens because it's going to be pretty important for Redshift. But all right, cool. Let's actually get to overriding some materials. So we're gonna actually let's load up my window view. Where's it at? Should be, huh? Why is it not here? Oh, there it is. And this just makes it a little easier to do what we're gonna do. Okay. And shrink this down a little bit. All right. So what we want to do is we want to first learn how to override some stuff. So right now, if we render this, and let's just save, let's make a quick little Redshift render. Just so we can see what's happening. And I'll give this a second. Alright, here we go. And actually it's using this camera. So let's lock that camera down and wait a bit. Let's move around. All right. And that's cool. So we can see kind of what's happening here. And let's increase the scaling. Let's do 150. So let's say we wanted to override some of these leaves or something, one of the group of leaves. So how would we do that? You know, and right now we're only going to do it on a single tree object, and then we'll look at doing it when there's multiple instances. So let's pause this. And if we jump into here, here's our material. And if you guys are wondering how this window came up, it's the P key. You just hit P and it pops up. So inside of here, let's stretch this out a little. We've got 1, 2, 3, 4, 5, and 6 different leaves. And so this tree is the summer tree. So let's say we wanted to make the green leaves different. We wanted to override the green leaves. So in order to do that, let's do a couple examples here. So we're not going to use the local overrides. How this is going to work is we're going to use material style sheets only. And so in order to do that, let's come up here. We could do it with a new window, or actually we'll split this window. So let's do that. That way we'll have some room here. And we're going to right click this, and we're going to switch to the data tree. And we're going to click on material style sheets right here. So this will give us our material style sheets, and here's all our objects in our scene. So let's save this again. So this is our summer tree. So this is our, here it is right here. What we're going to do is we're going to right click this, and we're going to click add style sheet parameter. And that'll give us these new options here. And let's just filter so we don't have to see the rest of this stuff. We're going to just do a filter for quaking, Aspen. Oops, why did it not? Did I spell that wrong? Huh. I guess it only works on the filter of an actual style sheet for some reason. I thought it would actually filter these out so I don't have to see them, but I guess not. Okay, well, our next step is we're going to right click the style sheet parameter, and we're going to add a style. And so we're going to just rename this, and we're going to call this green leaves, so we know this is our green leaf parameter. And style sheets, material style sheets, have order of operations, and so the higher up they are, the lower in the chain of operations they are. So they happen first, and then if I have another style on top, it'll override these. So something to keep in mind, and I'll show you an example of that as we start to layer this up. So now we've got our green leaves, and this is our first style. So now we need to add a target, and what a target means is what is this supposed to override. So let's switch over to materials here. So we've got leaf spring 1 and leaf spring 2, and actually let me check if we're using both here in our material. Leaf fall, spring 1, spring 2. Okay, we're going to override spring 1, and let's rename this actually to that. So rename. Why did it not? Leave spring 1. Okay. Because that's what we're going to override first. And so our target is a primitive. We're not doing point instances. And we're not doing the whole object. But for example, let's do an object. We're going to override the entire tree shader. So if we do an object and we right click this, again, our target, and you add a condition, you have to choose something like, oh, is it an object path? Is it an object category? Object bundle? What is your value? And actually, we don't need a condition for the whole object. What we need now is, since we're just going to override the entire object, I'm going to right click our leaf spring 1 again, and we're going to click right here where it says add override, And this is our override. What are we going to replace? What are we overriding? And so you have a couple options. You have to set the material, the render property, the material parameter. The ones that are most important are these three. We're going to be dealing mostly with material parameters and setting a material. So let's just set a material. And here you have the override type. Obviously a material because we're setting a material. And you have an override value. So if we click this, you can select. And so we're just going to do gray, just so you guys can see. So what's happening now is our summer tree, which is this object, we have a material style sheet override called leaf spring, even though right now we're only selecting the entire object, and our target is the whole thing, the entire object. And what are we doing? What are we overriding? We're overriding we're setting a new material, and that material we chose is material gray. So if we render this and let's save, what we should get is the gray material on everything. And we'll give that a second to process. And there you go. So you'll notice now that the entire object has our gray material. So what basically this did is, even though we have the material SOP here, this is basically saying the material style sheets take over. They have the highest precedence. So even though you have a SOP or an override here, it doesn't matter. The material style sheet will come first. And so we're choosing to override, apply material style sheet to this tree, this object right here. We're calling it this. The target is the entire object. So what this is doing, if you want to think of it, it's basically doing this. If you were to come up here and assign that material here, this is kind of what it's doing. It's going object level, place a material, and the material we chose. So hopefully you guys kind of understand what that's doing. But let's say we don't want to do the whole thing. This is really useful though. It's powerful stuff because it lets you override any object. So if you want to debug your scene or whatever, you could do it this way. That way you don't have to actually change your shaders inside of your object and have to redo them or any of that stuff. You could just do this, boom. And if you're done debugging, you just click this little checkbox underneath the stop sign, and it'll go back to normal. That's what this does basically. This disables whenever you check any of these off, it disables the style sheet. So it's going to go back to the regular shaders right here. And there you go. See? So we didn't have to delete this to override it or make a new material, and we didn't have to delete this. We could keep it. All right. So how do we stack these together? So let's say I want to now make and actually let's rename this again. We'll make this the total tree. Just whole tree. So let's say I wanted to override only those leaves that we were talking about earlier, the spring 1 leaves. So how do we do that? We make a new style sheet. So we add a style. We're going to call this the leaf 1 spring. And we're going to add a new target. And now instead of the object, we're going to use primitive. And so what a primitive is I'm sure you guys know by now, it's polygons, basically, faces of objects. And now we're going to add a condition. And so what a condition is we're telling it we want it to do a primitive, but what primitive? Do you want all the primitives? Do you want a group of primitives? What do you want? And so there's several ways you can control this. You can use primitive names, attributes, object path, object category, bundle, primitive group. This is what we're going to mostly be using, and so on. And there's actually another way you could do this. Let's delete this condition. If you right click the target, there's an option to set target from viewport selection. And so what this lets you do is select in the viewport. And since we already have groups, see, this makes it easy. You don't have to type in the group name. So the one we want is Leaf Spring 1. We select that, press enter, and it automatically picked it for us. The primitive group, Leaf Spring 1 mat. Now, of course, if we didn't do it this way, you can always type it in. The primitive group, you just go to primitive group and type in the name if you want. Obviously, doing it this way is a little easier because we already have our groups, right? But you could also do it like if you don't have any groups, you can even just select in your viewport polygons. You could just right click and select certain stuff, which is pretty neat. So let's show an example of that. From selection, and you could select the entire thing like this. You could, depending on the selection mode you have up here, there's different options. This already has groups, so it's just highlighting automatically all the groups for me. I'm not sure if I could select partial pieces of geometry, to be honest. I don't think it's gonna let me. And if you hold control, you can delete groups also. So let's say I select the whole tree, but I don't want the trunk. You can hold the control key and it'll turn red, and it'll get rid of that selection from your group. Yeah, but anyways, it lets you make selection sets that way. And actually, maybe I can do it. No, I guess not. It's probably only gonna. Yeah, it selects the whole thing. Okay. But anyways, let's go back. So we want Spring 1. We're gonna hit enter. And for some reason it did not do it. Oh, it's because I'm not in the mode. Let's right click, target, Spring 1. There we go. So we've got, this is our target. So let's right click our Spring 1 again, add an override, and we're going to set a material. And let's actually go to the materials section, and let's just make a new material. We're going to just copy this. We'll call it red. And we'll just make this material red. And so we're going to override using red. So we're setting the red material. So what's going to happen now is, because of the order, the whole tree's first going to get the gray material. And because this is next, this is going to go on top of the whole tree gray. So now these leaves that we selected, this group of primitives, is going to get the red shader. So let's render, and you guys are going to see what I mean. And by doing this, you could basically layer all the overrides you want that you can imagine. And so you guys might say, so now our gray tree is the first override, and then the second override is we're adding these red leaves to only this group. So as you guys can see, this system lets you just start layering changes and overrides without actually having to... It seems a little complicated at first, but once you get it, you realize how powerful this is and how useful it is, because it lets you add variations. So for our next, let's do another next override. So let's right click here, and we're going to do a new style. So this is going to be on top of everything else. And for this new style, we're going to right click, add a target, and do a primitive, and we're going to add a condition, and we're going to do a primitive group, and this time we're going to do the same but leaf 2. So that's another group. And we're going to do another override. And this time, instead of setting a material, we're going to override a material parameter. And so I'll give you guys an example of how this works. The shader we're going to override is matte gray, because that's what is currently assigned to everything. And so what we're going to do is, if we click on the override name, you'll get this list, and inside this list you'll have all the shaders. And so there's a trick to this. Unfortunately, just like earlier where we had to, in the material, for our random texture material, we had to add our parameter on top of the object builder. You have to do the same thing for material style sheets to work. So it'll work like on this. It can override any of these parameters, but when they're inside of a material builder, you have to expose them to the higher up level. It can't, unfortunately, you can't go inside. So if I click this, you see I only have OpenGL and settings, these. I can't go inside of this and edit it. But if I were to click on red, for example, you get all the properties. So you get base properties, diffuse, reflection. You get all these parameters, and you can control them. So that's something, unfortunately, I don't know why Houdini has that limitation. Hopefully they change that in the future. But yeah, right now inside of a material builder you cannot go inside and edit it, which is kind of a bummer. So what we're going to do is we're going to override the gray. So we're going to override the color. So we're going to go into gray, we're going to go into base properties, go into diffuse, and color. Now, if you guys know the names of the properties, you can just type them in. You don't even have to deal with all that. And so, diffuse color, that's the name. And if you want to find out the name of the properties, just put your mouse over it, and you'll see parameter diffuse color. That's the actual parameter. So if you guys don't want to dig through, you can just keep your mouse over, and you'll see the parameter for this is REFL, which is short for reflection underscore BRDF. Or IOR is reflection underscore IOR. So that way you don't have to dig through the folders if you don't want to. But if you don't know, then you can just do it this way. And so now we're overriding the diffuse color, and the override type, you have options. So you could use a string. This is what we would use to override a texture. Numeric, which is numbers, integers, floats, stuff like that. So that'd be if we would use this if we were overriding the weight or the roughness. But since this is a color, we're going to override with color. And the other options aren't really relevant for this tutorial right now. And so here's our color. We're going to choose a blue. Oops. And I don't know why it moved it up. For some reason. That was weird. All right, so because changing the order changes everything, just so you guys know, like I mentioned earlier. So right now, here's our 3 override commands. The whole tree gets turned gray. The leaf spring 1 gets turned red. That group, material group, and then this material group, leaf spring 2. We're going to override the material that's already there, which is gray, and we're going to override it to be blue. So if we hit play, there's only two materials here. Material red and material gray. And this is only controlling material gray to be a different thing. So that's what makes this pretty powerful. You don't have to So you don't have to have tons of different materials. You can have one material and you just change the parameters, these options it has at this level while keeping the same material. And so that's useful because you're basically not using as many shaders. You're just overriding the parameters of the shaders at render time. So as you guys can see, this is our result. We've got our, let's do an IPR. We've got our gray shader all over the tree, and then our red shader is being applied to leaf spring 1 mat group, and then our blue shader is taking our gray material and changing the diffuse color for us. So hopefully that's making sense to you guys. And so doing this, you could, as you guys could imagine, you have just countless possibilities here. So now the question is, how can we use attributes, right, to somehow influence our shader? And so we're going to use point attributes to instance this tree a little bit, and we're going to use the random attribute to kind of control the color that gets applied next. So let's duplicate this tree, and I'll just I'll just do it real quick. So let's zoom out. Let's go to object, and let's just drop an instance node, jump in here, delete that. I'm gonna just do a grid. Let's make it 25 by 25, 4 by 4. Yeah, that should be fine. And we're going to instance our summer tree. And there we go. We should have all of them showing correctly. Four by 4. It's kind of weird that it's displaying that way. Even though it's showing 3 by 3, I don't know why it's doing that. Okay, that's, I don't know, that's like some sort of display error. But 1, 2, 3, 4, 5, 6, yeah. Yeah, I don't know why it's doing that. That's weird. But okay. So this should be giving us, let's do a quick render, 16 trees since it's 4 by 4. And let's see what it does. Yeah, so there's 16 trees. They're all identical. And maybe actually a better example would have been, well, no, we'll do this. All right, and so we want to randomize the parameters that get chosen here. So how would we change not only on the individual tree overrides or different materials or change parameters? How would we do it per instance, right? And so that's going to be our next example here that we're going to try out. And so in order to do that, we need to feed our style. And let's actually rename this first. Let's call this parameter override. And so we need to feed this an attribute. And so if you guys have seen my other instancing tutorials, you know, you use attributes to make random sizes and rotations and stuff like that. And so we need to feed this data to this so that we randomly get different changes based on attribute changes. So how do we override the material on something that is scattered using points, using packed primitives or instances? And there's a way to do it, but unfortunately there's also a problem. And so it's kind of a limitation both on Houdini and on Redshift. It goes both ways. Basically, you can override a material on an entire point and the object, but unfortunately, because Redshift does not support CVEX, we can't override a material group, like let's just say the bark, on specific points. You have to actually override the entire object's material. And so that's one of the limitations that we currently have and one of the problems. And so what I mean by that is, okay, here we've got our tree, right? And we're going to disable for now our overrides. Or actually, let's keep our gray override. So the tree shader is gray. And we're going to come into our instance. I'm going to right click this. And we're going to add a style sheet. I'm going to right click this again, add a style. And we'll just rename this to point. Override. And we're going to right click this, and we're going to just select from the viewport. And we actually want to use points. So we're going to select points, and we're going to just select the front row. And we're going to hit enter. And let's come back out. And so you'll notice that we have points 12 through 15 selected. And we're going to add, where is it at? The override. And we're going to do a material override. You could do material, render property, material property, whatever, the same way we had up here. So we're going to just override this to the red shader. And so if we render right now, we're going to only get gray trees, and the front row should be red. So give this a second. And actually, no, I messed up. It should be right here where it says the properties. Our target should be point instances, not primitives. And so for point group, we're going to pick that. So earlier, so let's try this again. And this should now be red. And this will also, this technique will also work on packed primitives. So I'll give you an example right now. So you see, so now we've got, and I don't know what happened to our viewport. Okay. So points 12 through 15, which is what these are. So if you want to check right here underneath the camera tool and the render viewport tool, there's this little, I don't know what this is. I think it's a magnifying glass or something. And using this, you could actually highlight over an object, and it'll give you information. So it'll say instance 1. And if we go inside of there, where's our instances? And what mode is this on? Inspect primitives. There we go. Let's go back up. You'll notice that we have primitive 7, primitive 6, and so on. This gives you information so you can kind of see what numbers are being selected. Primitive 2, 0, and so on. So you could use this to kind of highlight your objects and see what they are. And so this is useful if you want to just kind of figure out the path of an object. But anyways, what's happening here is we can override the shader of the entire object, but I cannot, and I've tried every way possible, and I've even spoken with Wango, the Houdini dev, about this, and we've basically come to the conclusion that it's not possible to select a specific group on one of these points to override without using CVEX. And unfortunately for us, Redshift does not support CVEX, and according to Wango, it might not be possible in the near future because it's something really hard and complicated to kind of code over. So that is unfortunately one of the limitations. So for this tree example, we're not going to be able to, on per points, override just the bark or just the leaves. We can't do it. It has to override the entire material assignment to the object, which is, you know, like I said, a bummer. Because we can't change the parameters on a per shader group level. And there's just absolutely nothing we can do about that. And I've tried every combination you can think of, you know, adding a sub-target, and our sub-target being primitive, and a condition being a primitive group, and that primitive group being bark mat, for example. And what happens is it just doesn't support it. And the reason is because these points are being packed up, and so Houdini doesn't know about the group data in there anymore. It only knows points because it's instancing on points, you see. And so it doesn't work. So unfortunately, that is a limitation that you guys need to be aware of. So this will not work if your object has multiple shaders assigned to it. So that's a limitation, and to randomize shaders at that point, you might as well just use the attribute and a shader switch, and switch between that using the user data and the attribute you're feeding into it. That's the only way I can think of. And I've already shown how to do that in a previous tutorial. So this is a limitation for objects that have multiple shaders assigned to them, unfortunately. Now that we've gotten that out of the way and you guys understand that, let me show you an example of how you still can use this on individual objects with one shader. So we're gonna actually let's disable this, and let's disable that, and we're gonna go back to our example, and let's hide our instances, and we're gonna do another example of the random images. So, and actually let's do a material override so you guys know that this is using this method. Let's slide this down a little bit. And actually I should just delete this. We don't need that. And we're gonna do this. We're gonna do the same thing we did up here. So if we activate that again, and actually let's just delete this. So if we render this real quick, if you guys remember, that's weird. Why is it? Oh, it's because it's on the ground. Oh no, yeah, it should be visible here. Why is nothing showing up? Copy to points, back primitives. That's strange. What is going on here? Material. Hip textures. 1 through 20, blah, 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 blah. Yeah, this should be working. Strange. Let's initialize that again. Let's go to the materials. Is this invisible? Instance top level primitives. Our material gray. Random texture material. Yep, C. Randomization. Let me just copy this. Might be that it's not liking the hip path for some reason. Let's try that again. Huh. Are they under the ground? I think they are. Okay. Let me let's hide the ground. Yeah, that's strange. The object's invisible for some reason. Okay, I'm gonna have to pause this because I don't know why our object's invisible when it shouldn't be. So give me a second while I figure this out. All right, guys. So I figured it out. I noticed the copy to points had pack and instance unchecked, and at the same time I have instance top level pack primitives. So that's why nothing was showing up, because this means it's looking for a packed instance, and if there's nothing, nothing renders. So if I check this back on and we render, we have our packed instance. Unfortunately, it looks like our material now is not showing up like it was a second ago. So if I take that off, if I take that off, jump back up, and turn that off, yeah, there we go. So now we're getting our material here, and we're getting our random textures, right? And so right now we're using the override method, and actually let's come in here and fix that to $hip. Let's reload here. Yeah, and so we're using this method, and actually let's see if we can get it to work. No. So yeah, the moment we start to use the packed instances, it does not work anymore. And so the way around this is to use material style sheets. So we're going to keep, let's pause that. We're going to keep pack and instance on. And so these are still actual instances, but we're going to now control what falls into here using an attribute that our material style sheets are then going to read. And so that'll let us randomize it even if it is packed. And so let's jump back up, and actually let's hide this, and we're going to call this material, or we'll just say style sheet. And so this is actually going to keep packed, and let's disable packed on this so that way you guys don't get confused why it's not working when you open up the file. So we're going to come up here, and this is going to use the packed prim method, and like I said, the texture is not going to work using this override system because the information isn't there anymore. These are treated as points and not primitives. So if we middle mouse click here, you'll see that it's packed geo 25. And so what packed geo does is it basically tells Houdini and now Redshift, because we support packed primitives, is instead of treating this as an individual polygon and this as an individual polygon, compact it into a single point and make all the points use the same primitive asset, so basically instance. So let's in order to use this now, we basically need this parameter actually, but instead of having it at the material level, we actually need it as an attribute that the material style sheet's going to call upon. And so let me to explain that, let me think of a way to explain this. Essentially, what we're doing is instead of having this as a material string override, we're creating an attribute using this same string. So let's delete that actually, and let's just create an attribute. Let's connect it here, and we're going to call this rand underscore text, and so that's random texture, right? And we want this to work on points because that's what these are. They're packed primitive points. but the type is we actually want a string. And what this will let us do is that we're basically going to tell it to be controlled by our string expression that we wrote. And so we're going to just paste back in this expression, right? And so now if we look up here, let's lift this up, you'll notice our random texture attribute. And let's move this to the side. And actually, for some reason, it's only loading number 12, which doesn't make sense. Oh, I know why. It's because our expression right now is using $PR, which is primitive. We want $PT, which is point. Yeah, there we go. And so that fixed it. So keep that in mind. Now we're referencing each point. And so it's basically random texture, and it's telling us for every point, randomly select, you know, texture 14 or 13 or whatever, depending on the random point that we select. So yeah, you guys can see how this will generate our random points, right? And reference random textures in that folder randomly based on this script that references each point rather than the primitive. And actually, this might, let me think about this for a second. This might actually work. Let's go up a level and let's hide that. That might actually work for this when they're packed. If we, let's see, if we pack this, we pack an instance, and instead of referencing primitive number, we reference the primitive points, since these are points now, and we render. This might work. Oh no, guess not. I was hoping it would, but it does not. Okay. So never mind. That will not work. So back to the old way we had it. Okay, well, so now you know that if you're going to override the individual at the shader level on the material group, you can't use packed primitives. So something to keep in mind. And if you do need to use instances or packed primitives, you're going to have to do it this way that requires material style sheets. And so there's several ways you can actually generate this. So this is using a string, which is just, you know, it's telling us make an integer. I want random numbers for the points, and I want 20 options, 0 through 20 random numbers. Now, that's using a string. If you guys don't want to remember this or forget it, like I said, you guys could always do a lot of this stuff just using nodes. So let's just make an attribute create. We're going to call this rand. And so it's starting on points, and the type is an integer. So if you think about what this node is doing, it's the same thing right here. It's random on points, an integer, right? And so that's what this node's doing. And in order to randomize it, we're going to call this rand again. So now it's going, here's our attribute rand 0 through 1, but we want 20. And so it's going 0 through 20 now. So what these two nodes are basically doing is the same thing that this little expression's saying. It's saying I want random points between 0 and 20 that are integers. And that's what this is. On points, integers, 0 through 20. You see? it's the same thing. And so now to make it work on a texture, we just got to make another create attribute. And this time we're going to call this just text random. So it's texture random. And let's just select it. And you'll notice that right now it's all zeros. So we want to get this rand number and put it into here. And so what we're going to do is actually we're going to just copy this. And we're going to make it a string. Paste it into here. And now instead of using this little expression, we're going to just use the attribute we made, rand, @rand, with the 2 backticks. And there you go. So now it's using this to control this. The rand attribute we made using with these 2 nodes is now controlling our texture string. So if we go all the way to the right, you see it'll be 8, 16, 11, you know, whatever, right? Random numbers. And so you could always do things this way. So this does the same thing as this. They're both creating, this is just doing it in one node with a short expression here instead of having to generate the attributes manually here. And so this is just using our point number as the base attribute and then randomizing it, while this is just going on top of our points and creating a new attribute called rand, and then we're randomizing that attribute, and then that's what's controlling the number that gets generated after the underscore on the texture, right? So both of these ways will work. So we're going to use this method right now. And now we with this string here, this data in an attribute, we want to now combine this with a material style sheet that will then override our textures here, right? So this is called our random image texture style sheet. So we're going to look for it. It's right here. We're going to add a style sheet parameter. We're going to add a style. We're going to add a target. And we're going to add an override. And so our target is point instances because these are points and they're copies basically. And actually, let's just override the whole thing so you guys can see what's happening first. So, and instead of a material parameter, we're going to do the entire shader. So let's just do red so you guys can see. And then let's just render. And so now everything's red, right? And so what we want to do is similar to what we did earlier. We have our random texture map. So if we render this, it's going to be one number. Or wait a second. Set materials, random texture map. Let's go to our materials. Why is it diffuse texture? Texture 14. Huh. It should just be reading one of these textures, and for some reason they're not visible. That is strange. There we go. I don't know why. Huh. It just wasn't showing up in the format. So let's just try 14. And it's still not showing up. That's strange. Is it not assigned? Oh, okay. Yeah, just the texture wasn't assigned. So if I go into the object Yeah, because we have our override here. So if we actually delete this, we don't want this anymore. So let's clear that. And that's why if I clear this, it should still work. Oh no. Huh. Group. Match on points. Let's see. Nope. That is strange. Let's see here. There we go. I just needed the material higher up. All right. And come to think of it, let's see if that'll work up here. If we instance back in instance, and let's activate that. No, yeah, so that won't work up here because the data is not available to override the points. Well, let me see. Maybe I could do it with primitives. Or not primitives. Points. Let's try that again. No, yeah, it won't work. So it won't work for this. Let's combine that again. And we can't pack an instance. So let's disable that. Let's come back in here. And okay, we're back to where we left off. So right now we should have the 14s. So anyways, when we now that we've got our texture selected, which is the mat random texture, right? We want to override the numbers here. So in order to do that, we need to feed the random texture attribute, which is this random text, to manipulate this. And so in order to do that, there's the I believe it's called attribute bind, and that lets you bind an attribute into the override. And so how that works is basically we've got our override here. We're going to right click our style, and actually it's cutting off on the screen for you guys, but you'll see something called an override script, and it'll make this. And so what this does is basically it's a way for material style sheets to read attribute data from your object. And so now we're going to change is a parameter. And so if you guys remember earlier, we added at the top level the diffuse texture, this right here. And the reason was because material style sheets can't go inside of material builders, unfortunately. It can only work at the top level. So again, reminding you guys that if you are using material builders, to add the parameters you're going to change up here, because it's necessary. And when it's just a material at this level exposed already, then you don't have to worry about that. So since we already have that made right here, we don't have to make it ourselves again. And what we're going to end up doing is on the override name, you could either select it here, or you could just highlight right here and it'll tell you what parameter we lifted up, which was text 0. So, but we'll just do it this way again so you guys can see what it is. And you'll see right here diffuse texture 0. So now it's written down as text 0. And inside of the override type, you want to actually select attribute binding, which is the last option. And here is where you would type in your attribute. So we called this, let's go back to our object. We called this attribute, the randomizer, ran text, right? So we're just going to copy that, paste it here. And now, in theory, this should give us random numbers. Yeah, see? And so this is a way to get around packed primitives to randomize. And like I mentioned, this works only when the object, you're overriding the entire shader on the object. Unfortunately, yeah, without CVEX, this won't work on material groups of an object. So like our tree that we had earlier, I can't, this trick will not work on just the bark or something like that. It's just an unfortunate limitation that we can't do anything about until either CVEX gets supported or Houdini somehow allows you to target inside of the points. But I don't think that'll be possible, because that's what's keeping this ultra light as a packed primitive. It's treating it like points rather than an entire object with group data inside of it. So as you guys can see, this worked here. Let's do another example. Let's we're going to override it, but we're going to use this attribute data here. So let's actually plug that in down here, and we'll plug this in. So now we have not only the rand text, but we also have text rand. And actually, instead of making the random texture, or actually no, let's unhook this, because I want to keep this as an example for you guys. But we're gonna just make a new attribute. So we're gonna call this let's just do an attribute randomize again, and we'll call this I don't know, tint. And we'll just plug this in, and this is going to be a float. We actually want it to be a float. And we'll have 0 to 1. And so let's highlight that. Let's go up to our material, and let's dive into here. And inside of our texture sampler, if we go to the adjust section, there's the color multiply. We're going to highlight the little gear, and we're going to select promote parameter. And so now it's up here. And we're going to call the multiplier is color RGB, which means we actually need to control this with a 3 vector. So let's give this 3 dimensions actually. And so 0 to 1 random values. And now let's make another style, and let's add another target. I'm going to do point instances again, and we're going to set the override parameter and an override script. And so the parameter we're going to override this time is the color multiplier. And now you could actually do it here like this if you want, or you could use So let's actually show you what I mean. So if we actually start that up and we switch this to something dark and reload, that will darken it, right? And actually, something I forgot to mention is if you want material style sheets to happen in the IPR live, you need to go to the Redshift ROP, and in the IPR section, there is IPR live update style sheets. And so that's disabled by default because typically you're doing these kind of changes on some pretty complex, heavy geometry, and you already kind of know what's happening since you're the one typing in all the attributes and everything manually anyways. But that when you activate that, you could get live results. Well, I guess it doesn't work perfectly from the looks of it. It's actually bugging out. So, matter of fact, you're better off manually reloading because yeah, it seems to not work that well. Actually, I'll probably report that as a bug since the that should be updating live, but I guess it's not, which is pretty weird. Maybe it's due to fast processing. Let's see. Nope, it's just a bug. So, yeah, don't even bother using it. Actually, just manually reload. So anyways, you could control that like that, like I mentioned, or we could use an override script and do it that way. So, and actually, why is it material parameter? Named. Oh no, here we go. Color multiplier. Actually, let's see. Color multiplier. Color with JSON numeric. Huh. Guess I can't just override this like that. And actually, no. Yeah, you can't. We can do this. So instead of an override right here, we're gonna do an attribute override only. So let's delete that. And so we're gonna adjust the color multiplier, which is the texture tint that we added earlier to the material. And so if we come up here, that's what this is. And we're going to use an attribute binding, and this should work with our attribute we made earlier. So if we come up to our object, and we have this attribute tint, and it's going to randomly select for each of these numbers. It's like a CD attribute, actually, pretty much. It's doing the same thing. So if we render this, yeah, see, we're getting random color values here to multiply on top. And so we can actually control this if, let's say, you didn't want, you wanted certain colors. So this is RGB. So if we made this 0 and 0, only the blue values are going to be randomized. So if we press play here, now we've got random blues, right? And so using this, you can kind of control the color scale. So if we hit, let's just drop down a color SOP, and let's say you want I don't know, something like, I only want this baby blue color here. And so let's paste that in. And it kind of will lock in your values into those ranges. And for our minimum, we want, I don't know, oops, let's pause that. We only want something like this, for example. This will basically give us some colors that are in that range of values. See? So we're getting a little bit of hue shifting, but they're mostly between this darker blue and the baby blue wherever we had it. And we could also shift it to the purples if we wanted to. And let's pause that. Let's just copy this again. Paste that in, paste that in. And see, now we've got mostly that baby blue color with a little bit of purples. And so using this method, you could not only vary the texture, which is what we're doing up here, but we're also adding variation to our colors using a random minimum and max, which is basically RGB or XYZ. You can think of it that way. And so you can do this with pretty much any attribute you can think of inside of your material. So you can think of the overriding a script using the attribute binding and using an attribute that's XYZ, or if you need to change an entire texture, like a path, then you could do it this way, using rand text. Right? And so, and obviously if let's just copy, paste this down here. If we were to do this, instead of using this attribute, we could use the attribute we created here, which is just rand. So we'll just switch to rand here and render that out. And for some reason, we're getting nothing. What's going on here? Text. Oh no, that's why. It's text rand. And if we hit play now, there you go. Same thing, basically. The numbers are different because the randomization is a little different than if we used this, because this is based on point numbers, while this is generating the rand first. So the seed is a little different. But the idea, the principle is the same, as you guys can see. And so using this, you can actually randomize entire objects all you want and manipulate the shader. So if you wanted I don't know, adjust, let's do another adjustment on this. Let's so if we come up to the material and we come in here, and let's say we wanted to adjust I don't know, the refraction. Yeah, let's see if I turn on refraction. No, you're not. I don't think you're even gonna be able to notice the difference. Let's because there's no thickness. So yeah, I don't think that'll. Well, yeah. Here we go. but it's not. It's just not updating live on the IPR for some reason. Okay, yeah, well, this is a good example because it's obvious. So let's say we wanted to control the refraction or the roughness or whatever, right, on any object. We're going to, once again, you have the property you want to control. You click promote, and now it's up here. So we've got REFR weight, and it's at the top level now. So let's now control this. Let's add a new style. Let's add a new target. And let's do another override script. And this time we're going to select the reflection weight or refraction weight. And again, we're going to do an attribute binding. And this time though, let's go back up a level to our object. If we come in here, now we need to make a single float. So we've already done overrides using strings. This is the string override. We've done overrides using the RGB, which is what the tint is, RGB, using 3float. So now we want to actually manipulate only 0 through 1 on one channel. So we're going to just copy this again. Plug this in, and this time we're going to just call it, we'll just call it refraction, or refrand for refraction random. And now we want only one dimension, so these don't matter, and we're only focusing on one float value. And so refraction at 0 means it's solid, 1 means it's transparent all the way. So we want to randomize that value. So let's make 0 fully solid and a maximum of 1. And if we wanted to just have it on or off, we could use integers rather than float. So float will give us the values all the way through. And if we were to make this into the an integer, it's either going to be 0 or 1. So it means it's solid or transparent. Right now we're going to have everything in between, but you know, that's fine. Let's just see what happens. So refrand is our override that we're going to use. And let's just hit play and see what happens. And you can't really tell. Interestingly enough, refrand, I think our values just aren't, let's see, 0.4. Yeah, material parameter. Oh, yeah, that's why. Right now our target is on primitive. We need it to be on point instances again. So let's try that again. And there we go. So now some of them are more transparent. Some of them are more opaque. If we come under here, look at the sun a little more, you'll notice now the difference more. See? Cool. And like I mentioned, if you just want it on or off, then just make sure that this attribute, when we create it, referand, is an integer. And so that means it'll be either 0 or 1, as you can see here in our geometry spreadsheet. So now if I re-render this, see, it's either all the way transparent basically or not. And we're getting a little bit of reflection. Cool. Now let's say you wanted to target this not on everything, but on specific points. So let's say our random coloring, we don't want it on everything. We only want it on, I don't know, a couple. So we'll come into our style sheet for the random coloring. And actually, let's disable the, or no, let's get rid of the integers, so that way there's variation. So we can still see all the different points. And let's say we only want the random colors on some of the points, not all of them. So what we could do is on our target, you could either select from the viewport. So if we do that, we could just select these, this, and this, and just hit enter. And that will now only give us the random color tint on the ones we selected. So as you can see here on the values, it's points 10 through 14, 20 to 24, 16, 2, and so on. And if actually we copy this and we do the same thing now here, and so we add a condition, and we select point group and reload, you'll notice that these are now back to regular, just our white material with random numbers on it. And actually, let's do it on top of the random numbers too. So let's add a condition here and our point group. And so now all the ones that we didn't select are getting nothing basically. They're just not getting any material at all. Because this is setting our material here. And then it's randomizing our material. So actually, if we wanted something at a higher level, we would be able to make a new style sheet. Let's pause this. And we would drag this up to the top. And this would just assign our material, which is, where is it? Random texture mat. And so now, set material, add target, point instances. Let's try that again. Weird. Refraction weight. Yep. Style, set material. That's strange. What's going on here? Let's disable this. Now nothing. Set material, override, yep, render property. That's strange. Let's try this. Huh. Okay, that's a little weird. It should, the order matters here, but for some reason it's not. I'm not exactly sure why it's not doing it. Random texture map material. Yep. Yeah, that's odd. This should be assigning. Let's see if we disable all of this. And actually delete that. Yeah, that's strange. It should be assigning to everything here. And for some reason it's not. Let's yeah, that doesn't make sense. This should be working. Let's go to the material, and okay, this is why. For some reason it I don't know why, but when I added this, it removed our texture path. So let's add that back in. There we go. Yeah, that's weird. That was a pretty weird bug. So okay, now it's working. So now if I uncheck these and reload, there we go. So now we've added variation. You know, this is, what is this? 3 levels of variation. So the all our, if we think of it this way, if we layer this up. So our first style sheet is just our shader, regular shader that we already had pre-made, the one we made. And so our first level of variation is we're going to randomize the textures on there for only the points we selected. So if we reload, you'll notice that most of them are 14 except the ones that we selected. And then our next level of variation, so that was randomizing our texture here. Our next level of variation we chose to make is to change the texture color tint. And so now we're randomizing between that baby blue and that purple, because we chose a minimum and a maximum that kind of controls the random colors that are being used. And so that multiplies the color on top of the white texture we already have. Okay, that's cool. And it's only on the same points. We could actually choose different points if we wanted, but it's easier to show the difference when it's the same points. And then after that, we chose to add variation to the refraction to make those points more see-through or not. So if we were to go under this, you could see that some points are completely solid and other ones have different degrees of transparency. And that's what this final style sheet is doing. And so the order matters, you know. So it's doing this first, then this, and then this, and then this. And so hopefully you guys kind of see what's happening now, how this is working, and how it lets you randomize on the points that you have selected and the type of randomization on the material. And you can do texture locations, which are strings. You could do colors, and you can do 0 to 1 float values. And so that's basically everything. You know, you could randomize anything on a redshift material or a texture input. All those values can be randomized using this method, using either strings, colors, or floats. So hopefully you guys now see what's happening and how powerful this can be. And unfortunately, like I mentioned, it does not work on an object that has more than one shader. So this only so far works on individual objects with an individual shader. If I ever find a way to get around that limitation, I'll let you guys know and I'll make a tutorial about it. But unfortunately, according to the Huango, the Redshift dev, and what I've been digging about Houdini, it is not possible right now with Redshift unless you have the CVEX support. So in order to get individual overrides or switches, you still got to do it the old user data attribute approach. You can't do it with material style sheets, unfortunately. So, but hopefully that gives you guys an idea. And so we've gone over, several pretty in-depth methods here on how to control this and some of the things you could do. And we could actually probably apply all this and also rotate our material here in a similar fashion. And actually, yeah, let's actually try that. So let's come in here and let's add another attribute, and we're going to use our rotation randomizing HDA we made earlier. We're going to plug it in, and we're going to do random rotations of 30 degrees. And so now if we check in here, we should have oh yeah, we have to name the attribute. Let's call it rotrand. And so now we have rotrand values. And so earlier when we were overriding stuff, we were using the user data node. And actually we could do the same thing using material style sheets. So let's apply that here at the texture level. And so we're going to apply the same texture, obviously, that we had earlier, but now we're going to rotate. We're going to have a parameter override instead of just setting the material. So let's add a new style sheet. Let's come up here, add a style. And really, I don't think the order would matter for this, but let's bump it up here. Let's add a target. And we're going to just choose point instances, and we're going to do it to everything. So all of them randomly rotate. And we're going to have where's it at? The override script. And we're going to do a material parameter. And so let's go to our material again, because we need to expose it up here. We're going to come in here, and on our texture sampler, we have rotate. We're going to click this. We're going to promote it. And so now we have rotate up here. And so we're going to select rotate is what we're going to override. We're going to use an attribute binding, and we're going to use rotrand, which is our where's it at? The attribute we named. And so that's going to rotate everything around. And so if we hit render, there you go. Just like that, we were easily, as long as you have an attribute, basically, you can have it do anything you want. And so now we're getting random rotations. And let's even manipulate this further. Let's do from viewport selection only these middle numbers. And so the top and the bottom are regular, they're straight, and only the middle is now being randomized because we selected those points. So as you guys can see, this just the amount of variation is pretty much endless. You guys could can go wild and just do tons and tons of different variation this way. And you know, it's unfortunate that we can't do it on material groups, because this would open up huge doors for trees and stuff like that. So that right now it only works on individual objects. So, but you know, it's pretty powerful stuff to have already, and eventually, hopefully, that support arrives and we'll be able to randomize pretty much any way we can imagine. Now for the final thing that I'm going to show you guys is, so far I've only shown you how to assign the grouping, the point grouping, based on you just pick it in the viewport or you type it in. But let's say you wanted you had a group of points already made, or you want to randomly have points selected. So in order to do that, you need to actually, you could do it two ways. You could either write a group expression that's random, or if you have an attribute that's already created and you convert it into a group, that'll also work. So let's type in group, and you'll get the group expression node. And so we want this to run over points, not primitives. And we're going to just call this point group. Right? And so if we come in here, we'll have, where is it at? Why is, huh? Oh, well, we're not actually making a group yet. That's why it's not showing up here yet. So in order to, the point expression group, SOP, I mean, comes with already a randomizing group node. And so right now this is basically just select this and it'll give you a 30% chance. You could increase that chance by changing the 3 to whatever number. So if you make that 75, it's a 75% chance. 0.15 is a 15% chance. And you'll notice how the groups are being highlighted here and changing. And so now we have a group, and let's move this to the right. We have our point group right here, point group, and now it's showing up and it's highlighted for us which points are being selected. And so this lets you select random points, or if you guys already had attribute data created. So if we already had I don't know, up here we had like the referand, because obviously it's not going to work on a string, but we already had, or actually we would need it to be points in integers, so it would have to be our rand, and you would basically have to be able to make group selections with that, and it would be 0 to 1, so it's like on or off, and if it's a 0 it's a group, if it's not it's not. And then we would just convert those attributes into group selections for us. But yeah, I don't really want to go through all that right now. I think I covered that in another tutorial also, when we went over how to group the leaves, breaking up a leaf that was random, and then we used the group expression to control that. So like, let's say if you use the scatter SOP already, the height field scatter or whatever, and you already had, 0 and 1 data or something, and you needed to convert that into groups. So let's just create, I'll just go over it real quick. So we'll just call this group rand, and it's integer data, and we're going to randomize group rand, and it's 0 to 1. So if you see group rand right here, it's 1, 0, 1, whatever, right? So let's say you already have these attributes from, I don't know, the height field scatter or whatever, right? Some other SOP. And you just needed to convert that into groups. You could just do a group expression. We'll just call it, yeah, group 1, whatever. And for the vex expression, you're just going to type in the attribute you want. So this is just group rand. And I think it was called group rand. Yeah, 0 to 1. And, oops, instead of primitives, we want it on points, and there you go. Using 1 means yes, 0 means no. So grouped, 1 means it's grouped, 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 not grouped, and so on. And that lets you just typing in the attribute into a group expression node will just let you make a group out of whatever attribute data you want. Just make sure that it's in that it's been flattened down to 0 to 1 space, so it's not weird float numbers or larger than 1. So something to keep in mind if you want to use attributes from some other SOP. But we're going to just use a random, and right now I have it at 15. You could set this to, I don't know, 25. So 25% chance that it'll become part of the group. And we're going to use that to override our randomization of our rotation. So right now, if we render, only the middle ones are rotating randomly because that's what we selected earlier in the viewport. But you could also, if you put an asterisk, that means it'll select everything. So all the points now are random. But we want to control them based on a group we already have, or we want to randomize it. So that's what this is. And so this group is called point group. So all we got to do is right here we've got point instances and point group. We're going to just call it point group. And there you go. Only certain, the group that we have selected here, so if we show groups, and you can't really tell that much, but the ones that have the little dot in the middle and are part of the group, those ones are the ones that are being selected. And because that group has a name, point group, we can assign it here, and those are the only ones that are going to get the random rotation we made earlier. So actually, if we now do this, only those that are in the group are going to get the changes, you see? And then the rest are just our regular original style, which is just the texture by itself. So hopefully that makes sense to you guys. And you know, you don't have to have all of them be the same. The groups could be totally different groups. It's however you guys want to do it. See? So some of them are rotating, some of them are colored and are not rotating, and so on. So yeah, hopefully you guys learned some shader randomization techniques. I know a lot of the times people ask about this in the Redshift forums, and this information is just scattered all over the place, and some of it hasn't been updated, or people don't know about the new changes. And so that's why I decided to make this, because people are always asking about how do I randomize my textures in Houdini, or you know, questions like that. And so I wanted to go over how to randomize rotations, textures, how to use material style sheets to do all these things, and cover it all in one pretty lengthy video. I know this is a little advanced for some people and a little more complicated and complex than some of our other tutorials, but hopefully I went through it slow enough and explained everything for you guys, and you guys got to see how I made this Houdini HDA. And now forever, if I need a random UV rotation, I got this tool to do it with. And yeah, so hopefully you guys can apply all this knowledge in the future and be able to randomize your own shaders to fit your needs. And again, this does not unfortunately work when you need to assign individual material groups. In the future, hopefully we'll find a way around that, but for now this only works on overriding the entire object shader. But yeah, so again, thanks everybody that supports this Patreon. This is a little more of a technical video, but it opens doors for a lot of people that are wondering how to randomize their materials using material style sheets and all the powerful options we have to change textures, colors, float values for like refraction or roughness or whatever, right? So this opens up doors for a lot of people, and hopefully these examples were simple enough for you guys to understand. You guys again will get the seed file so you guys can come in here and explore what everything's doing and follow along with the video. Thanks again for all the support, really appreciate it. And yeah, I look forward to seeing any cool stuff you guys make using these techniques. Thanks.